Now I'm going to talk about a very interesting idea called machine learning. You can think of it as AI. Okay, I'm going to pick up my another talk quickly about AI. This is a general talk which I give to people, and all right, here we go. So I want to talk a little bit about machine learning. Okay, so how many of you have played Mario before? Do you think that it can be automated? Can a computer automatically learn to play any game which you show it? So this guy did it, as in he hooked the bot, he hooked a computer program to Mario. Okay, he hooked the computer program to the observe the state of the game, as in what does it look like, and the score. So the computer program had to press random keys to maximize the score. Computer program called, let's just call it bot. The bot has to observe the environment to see to see if it's winning or losing and press the random keys. Now let's see how it turned out to be. Okay, so let's look at it. So on the day zero, this is how it looked like. So the computer program, the bot, is continuously pressing random keys and doing nothing at all, and your Mario dies of old age. After after a day, it's moving a little bit further. You can see that it's a little bit further, but again, it's not too great. Okay, just looking a few frames in future and just got badly stuck. Few more weeks and you will be amazed this time. Few more weeks, it's playing better than me actually. You see that? Okay, so it's, yes, you can see that it learned by itself by playing it again and again. But it got stuck. Okay, you can see that Mario is not having a problem at all. Now few more weeks and now you're going to see the magic. It's better than most of us. Okay, it is better than most of us, and you are going to see something very interesting. Okay, look at this. Have you done this before? When the Goomba is falling on it, it's basically starts moving a little bit so that the Mario, the game thinks that it jumped on Goomba rather than Goomba jumped on it. So it figured it out by itself by playing it again and again. It actually hacked into the game. It actually hacked into the game. Nobody ever knew about that bug before discovered by this program. Okay, so basically it, just by looking at the data and learning from it, it learned to hack into the game. And this is AI, this is machine learning. This is machine learning. Machine learned to play by itself by looking at the game and pressing the random keys and observing the score. So this is machine learning. Now, what is more interesting is that it's able to do better than what we do. It doesn't know the definition of gravity. It doesn't know the definition of an obstruction. It doesn't know the meaning of collision. It doesn't know the meaning of colors. But still, the bot has figured it out how to play this game to win it. Now the next scene, again, the program, I don't know how it did, but it's able to avoid falling. Again, the same program was hooked to play another games, hooked to play another games, and this time, so it was hooked to play Tetris. That it could not play Tetris better than the people, but it's still trying. But what amazed the people was that when there was nothing left, there was no step left, and it couldn't do anything, all it did was pause. Or all it did was paused the game so that it can't lose anymore. When it could not win, it can't lose anymore. And that's kind of intelligence we saw in our cousins or in our siblings in the childhood. When they could not win the carom board, they will just spoil the game and run. Okay, so this is the mark of intelligence. Okay, although it's purely based on data, we haven't taught the meaning of the gravity and the meaning of the world. We haven't taught them any we haven't taught anything at all related to the real life, but still it has figured out most of the things. Okay, so that is AI. Okay, so that's kind of what we are trying to do is we are trying to do the Mario with the real life. And how? In our case, what we just saw an example where the program was playing the Mario, we we did not create the data by ourselves. It created data by playing game again and again. So it has all the data available and applying intelligence, and then giving the feedback by pressing the keys. And same thing we want to do with our real life, solving the problems like the medical problems and all kinds of problems of the world. So basically, at one end, there will be these IoT devices which will gather data. Using these IoT devices, we will gather data what's going on in the real world on this big data technological stack. And then using intelligence as in machine learning or we can say AI, we will do the computation and whatever is the result of those computation, we will give the feedback back to these devices so that they can help us solve our problem. So this is basically the relationship between machine learning or AI with big data and IoT. Okay, so that Mario game actually is signifies a lot of things for the human generation to for next 10 years. Okay, so basically, what whatever this Mario did was a very simple thing as part of machine learning. And what it did was it gathered a lot of data and input data and output data, as in X and Y. And then by creating correlations, it started predicting the future. Okay. And that's basically the machine learning. Okay. So there are many libraries around for machine learning. Okay. And how is machine learning related to big data? Because machine learning requires a lot of data in order to give better predictions. Okay, so I mean it's a very obvious thing that if you have more data, you'll be able to predict better, right? And and therefore, bigger the data, better the predictions. Therefore therefore the usual machine learning tools, say R, SciPy, and and others like SAS, and most of these tools which provide machine learning libraries as in ability to predict the future based on the past data become the bottleneck when the data is used, meaning when they are about, I mean, when we say on one hand that big data solves the problem, um, I mean, bigger the data, better the predictions. Now if these tools can't handle the bigger data, then they can't really give the better predictions. Okay, so when the data is in petabytes, you need a tool like Mahout. Okay, it's a scalable machine learning library built on top of Hadoop, meaning you can do predictions based on terabytes of data without any problems. It is based on a paper by Angie and ETL, and it's called MapReduce for machine learning on multicore. Okay, so it started as a Lucene sub-project, but now and into around 4 years ago, 6 years ago, it became top-level projects. Although it's being rewritten for Spark, but still it has a lot of significance. Okay, so machine learning is basically programming computers to optimize performance using example data or past experience. It's a branch of artificial intelligence and is for design and development of algorithms. It's automatic de- development of algorithms. So instead of we writing the code, the program will automatically figure out based on the past experience. Okay, the way our bot figured out Mario. Nobody coded it. Nobody coded it to play like a champ. Okay, so it automatically played. Somebody basically hooked it to Mario to play. Like for example, recently AlphaGo, the game player, the machine learning game player for a game called Go by Google has defeated the world champion by a marginal victory, by a significant victory. And so basically, these machine learning libraries are performing great when the data available is great. All right. So there are many kinds of machine learning. One is supervised, other is unsupervised, and then third one is semi-supervised. Supervised is we clearly know the labels. We know that this is elephant, this is duck, and this is something else. When we have clear demarcation of input and output. Okay, that is supervised. And unsupervised is when we don't know. We have some data, we have no clue about what is input and output. There is no labeling. And semi supervised is where you have partial information on labels. For example, you crawl the data from the internet. Some of the images have correct name. Some of the images have don't have a name at all. So that's labeling. Okay. So unsupervised is like given all the news, can you just categorize them into four categories? Or given all the email, just categorize these emails on whatever basis into five buckets. Okay, there are many more applications of machine learning wherever as a general thumb rule, wherever creating the algorithm is really tough, machine learning solves those problems if you have data. Okay, and here is a very important slide. Basically, when you have few lines of data, you can do prediction by yourself. You can draw that data on the whiteboard and say, okay, last year we have this much sales, next year we will have this much sales, and here is the graph, and we will. So, so let's say we have, okay, so let's say we have a whiteboard and we have 3 points, and we say these are, say, what do you say, raw material cost and our profits. Okay, so we just plot the data for last 3 years. Okay, this much was the raw material cost last year, and this year the profits are like this and this and this. So if we have like 4 points or 10 points, we can take a pen and paper and just draw it and draw a straight line like this. Okay, now we can predict for future year based on the same line. Okay, if you have just few points, you don't need even an Excel sheet. Okay, so if you have like few data points, you can do use it whiteboard, Excel sheet, Microsoft Excel sheet, or any of those primitive tools. Okay, you can use pen and paper or you can use Excel sheet. But when the data grows bigger and bigger and you have got the data in MBs, then you can use R, Octave, MATLAB, or you could use Microsoft Excel. Okay, as the data goes beyond MBs into GBs, then then visualization, as in plotting graph and representing data in graphical form, becomes different than the analysis. in lower GBs, because it doesn't make sense to plot graph of GBs. Instead, you first analyze it and then you plot the results. Okay, and you use tools like Flare, MCharts, Raphael, and Protobase. And analysis you can use using NumPy, SciPy, and Veka, and so on. But if the data goes beyond few GBs, okay, then none of these tools will be able to solve your problem. Okay, first, at this point, the the memory became RAM became bottleneck, so you move to these better tools which can utilize RAM better. Again, the RAM and disk speed becomes slower at this space, and then you go when you go into petabytes, and therefore you need different kind of tools like Mahout, Giraffe, MLlib, SparkR, and GraphX, because they are distributed tools. So big data machine learning is here. Distributed machine learning is here. All right. Now, so for Mahat, the use case are collaborative filtering. So basically, in Mahat, you can do collaborative filtering, as in giving recommendations that since you like these movies, you may also like these movies. Okay. And clustering, as in given the articles of the world, just cluster them that which articles are similar or have the same content. Okay, classification as in this email is a spam, this email is not a spam. And then frequent item set mining, saying that because people bought these items together, okay, you are buying this, the people are buying these two more items with it. Okay, so the example we are going to take today is a recommendation, the simplest one. And this is a very important example because I've used it in the case of my recommendation, which I was working at in 2012 at InMobi, and this worked pretty well in Mahat. Okay, now what we are going to do is we are going to take the example of the recommendation. What is recommendation? Given the past history of what people liked, okay, we are going to give them the suggestions of the movies. So Sandeep liked Matrix, and they why? Because Sandeep has given 9 out of 10. Sandeep likes Casablanca, 9 out of 10. Kumar likes, so Sandeep and Kumar has given the ratings to various movies. Now, based on this data, Mahat is going to give the suggestion saying Kumar might also like Casablanca. Why? Because Sandeep and Kumar look very similar. Their one third choices are similar. Okay. So we started giving the recommendation from Sandeep to Kumar and Kumar to Sandeep. So what we'll do is we'll first download this data, 1 million movie lens data, and then unzip it, and then convert that comma separated data to something meaningful. Okay, so let's get started. So you can see, okay, all right, I'll have to delete some of my data, it's taking too much space. Okay, so let's just download the, okay, from data from here. Okay, I think, do I already have it? Alright, I'm going to download it right away. It wouldn't take too much time. So it has finished downloading a million recommendations. Let's unzip it. So, and I'm going to just take you through the kind of data we are talking about. Okay, so it has got 3 files. Fourth one is a readme. Okay, 3 files as in the details about movies. I'm using a command called tail, which will just show us the last 10 records. So you can see that it contains movie.dat contains the movie ID, name of the movies, and the genre of the movies. Okay, then we're going to say tail users.dat. Okay, user ID, gender, age, and some more characteristics. I don't know what it is. You can look at readme and it'll tell you what exactly is this. And the day, I think this is something else. Now, what is interesting to us is ratings. Ratings has which user, this user, okay, 6040, okay, who is a male of 25 age, okay, this user likes a movie which ID of which is 2022, okay, and the rating it has given is 5 out of 5. At this time, this is the time in milliseconds. And how do you convert it from the millisecond? You can use, I think you can use the, yeah, yeah, we'll look at it later. This is the timestamp since epoch. So you can see here that this user rated to this 6040 is the user ID, has rated 2022 movie. This is a movie ID, and with 5. Okay, it's saying that somebody likes Shashank Redemption and this much 5. All the ratings are 5 out of 5. Now, just giving this data, we have to provide recommendation. Now we don't right now use the information from users.dat or movies.dat. We are going to just churn ratings.dat. Okay. First assignment would be to convert this data into comma separated rather than double colon separated. We want to convert this into comma separate, and we only need first three values. We want to convert this data from ratings.dat. We want to convert ratings.dat into comma separated, and we only need first three columns. So right now, since this file is how much big? It's just 24 MB. Okay, so we can use either SED, PIG, or if the data could have been in GBs, we could have used PIG, but we will use PIG. Okay. All right. How will we use PIG? Okay, I think I have already kept this data in the this folder. We did not need to download it actually. Let me just check if it's there or not. Okay, so let's just check. Good, it's already there. So we don't have to do this. So we can say, let's load the data. Okay, let's load the data. How do you load the data? By saying like this. So note that we are saying pig storage colon, but our data is separated by double colon. Therefore, there will be few blank columns. Okay. Now you can see RD. Sorry, we can say describe RD. No schema is given. Now let's say we are saying for each generate. Since we have splitted the data like this. Now we can iterate over this. Okay, we can iterate over this and then store cd into ratings.csv using pig storage. Okay, now I'm going to just change the folder name. It's a folder name. Okay, ratings 6 fab. Okay, we are first loading the data from ratings.dat, which is already I have uploaded there under data ml 1m and ratings using separator as double column. Okay, now you can see here that for each RD generate 0th, 2nd, and 4th. Why? Because column number 1 would be containing empty because the data is double column separated, and then we are storing the data into this. Okay, in my home folder it is going to create that. All right, so we can say ls, and do you see somewhere ratings 6 fab? Do you see that? So we could say ratings 6 fab. Since we are giving relative folder, it will be relative to our home directory. Okay, so it has generated this. We can say part this, and let's see what's inside that part. Okay, you can see that the data has been comma separated. Okay, so all right, let's try to show you what does it mean by tail minus tail tail ratings dot csv ratings dot dat. Okay, this is our data, right? This is our data, correct? And if we split it by say colon with say colon with tab. Okay, if we split it by colon with we split it by colon, so what's going to happen is, okay, you can see that first column is this, then second is actually empty, and third column is this, fourth is actually empty here, see that, and fifth is this. Okay, that's why we are saying take zeroth column, because we start the counting with 0, 1 is empty, 2 and 4. All right, now since our data is ready now and it's in the ratings folder, in our case the data is in ratings folder. Now we don't need, now let's launch our Mahout job. Okay, so let's delete the previous data from HDFS. I've deleted my previous data from the previous class. Set my Java home. I just hope my Java works, because we keep upgrading Java. Now is the time. Okay, now is the time that we launch Mahout. Okay, we are saying Mahout recommend item based. We are saying Mahout, we are looking for recommendations, and then we are saying that use this particular algorithm. Our input folder is this. In our case, the input folder is ratings 6 fab. That's where we had stored the data using pig. And we are saying output folder is recos. Okay, output folder is recos, and I think we have not deleted recos. Okay, let me also delete recos. Okay, recos have been deleted. Now let's launch Mahout command line. We are telling Mahout that here is my input folder and please save the data to output. What will it do? It will basically do the work of recommendation. The format of the output is this user may like this movie this much. Okay, that will be the format. So it's going to take some considerable amount of time, maybe 5-10 minutes. It's going to have multiple phases of MapReduce. Okay, it's going to have multiple phases of MapReduce to generate the recommendations. Okay, so we gave the input pass history of users recommendations, that's it, and it's going to generate something of this sort. Okay, it says that user this will like this movie and might give the ratings as 5 out of 5. This user would like 1358 movie this much, meaning 4.5 out of 5. Okay, so that's the okay, so it's going to run the MapReduce. Okay, and yeah, there are these other recommendation algorithms. We are right now using log likelihood. There are many formulas which people have implemented in different manner. Okay, all right, so the program has finished, and you can take a look at the output. So where did we keep the output? In the records folder. We could say Hadoop fs minus ls records. Good. And we could say Hadoop minus fs cat and pipe more. Pipe more means show me the page wise. Okay. So here it shows that the user one would like, it has given the top 10 recommendation for the user one. Okay. And these are the recommendations for various other users. Okay. So you can see that for this user, it has given kind of, I think more than, yeah, it has given the 10 recommendation, but it has given decimal form. So this user is interesting because it has only, okay, okay. So you can see that the recommendation generated are really huge. Okay. So what you can do in this is as a modification that in the ratings that in ratings.dat you enter one more user ID for your own username, okay? And then enter all the movies from movies.dat which you like, and then generate these recommendations again. So that way you might get a good suggestions for yourself, okay? That way you will get suggestions for yourself in a very easy fashion. Or you can just open the movies.dat in Excel, and against every movie you could give the ratings for you and then add those entries into ratings.dat. Okay, you can give that a try. That way you will be able to have a new movie list to watch. Okay, so that was a quick demo of Mahout. So Mahout can do many similar things. It's basically a library of algorithms for doing the predictions or the machine learning. All right.